Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. Guten Morgen, liebe Sorgen. Ihr habt natürlich keine Sorgen, denn hier ist das Robotik-Häppchen um 6 Uhr am Montagmorgen. Mein Name ist Robert Weber und wir suchen einen neuen Partner für das Robotik-Häppchen. Wenn ihr also Lust habt, Partner zu werden, dann meldet ihr euch bitte bei Helmut oder mir. Und jetzt geht's los. Hallo, liebe Zuhörerinnen und Zuhörer, das ist das Robotik-Häppchen und wir gehen in den Urlaub. Mitte Januar sind wir wieder mit News am Start. Aber es kommen noch reguläre Robotik-Folgen. Wir haben noch einen Jahresrückblick, auf den ihr euch freuen könnt. Und für nächstes Jahr suchen wir auch noch einen neuen Partner für unser Häppchen. Heute haben wir noch einen Happen für euch aus dem Industrial AI Podcast zum Thema Safety und AI. Ein sehr cooler Ansatz. Das war es von der KI. Euch eine gute Zeit. Und jetzt geht es los.
Hi there. Welcome to a new episode of the Industrial AI Podcast. My name is Peter Seeberg and I'm your host. Today we'll be talking to Stefan Milz. He's the founder, managing director, and also the head of R&D at Spleen Lab. And Stefan and I are going to be talking about safe AI and also towards the end, their first endeavor with XLSTM. Hi, Stefan.
Hi, Peter. Thanks for having me.
You're welcome. To start, please introduce yourself to our listeners.
I keep it short. So I'm Stefan Milz. I have a technical background. I'm the CEO of Spleen Lab, also the founder. A technical background in physics. So I have a PhD from the Technical University of Munich. And then I worked several years in the automotive industry in highly automated driving for a Continental introduced there, working on the first NVIDIA series production project, ZFAS, and then for Valeo on highly automated driving. And during that time, had the idea to introduce something new, on-chip AI with a focus on functional safety, and I guess founded Spleen Lab, and this is the reason why we are sitting now here.
That's right. On-chip AI. I guess we're going to be talking about that. So to start, what does Spleen Lab stand for?
You mean the name itself?
Yes, exactly.
Okay, it's a funny story.
I believe so. Yeah, I thought it this morning when I looked.
It's a very funny story. And originally, I started the company in 2015 as a pure side project, right? And Spleen is translation of my surname Milz. So it only makes sense if you
understand the German language, right?
know German, right? And then this was. I needed in a fast way a name, right? And then when we really started with Spleen Lab, we wanted to have a different name. And then we thought, okay, this is so unique. You find it everywhere. Let's keep it because there is no mismatch with other companies.
Exactly.
And then we left it. So literally my surname.
Right. Your surname. And your surname happens to be the same word as for a human organ, right? But you have nothing to do with medical activities inside of the body of a human, right?
Also, we not excluded from future, right? As safe AI is a really important topic also in medical, but it's no focus at the moment.
Very good. Maybe we come to that. I mean, I've been saying time and again that everything is growing together, and that's an example of it. So when we talk about, and that's what we are, Industrial AI Podcast, and we do talk about industrial. Today we talk maybe a little bit outside even. You already mentioned here autonomous. We're going to be talking about your visionary approach. And at the same time, I would do the same thing. I would talk about how a physician, a physical doctor may be using very similar technology. So we will be talking about safe AI. Let's start with a quick definition of what is safety, maybe as opposed to security.
Exactly. So this is also a funny side note. In Germany, or in German, we have safety as Sicherheit and security also as Sicherheit. So this question is quite good.
Right.
When we talk about safe in the context of what we are doing at Spleen Lab, then it's meant to be functional safety. So functional safety is something, if we automate processes with heavy machines or with sensitive processes, then and all the time a human is in the loop, or there is a probability human could get hurt, then we talk about functional safety. And this is where we are working on. And there are real regulations in that field. They are there for many, many years. So in ADAS, we have ISO 26262, and now for the software, we have SOTIF. But there are similar things in aerospace like the DO 178. These are real process definitions that define how to develop a software or a system that needs to be safe in the context that it interacts with a human and no one gets hurt.
What I recall when I was more strongly involved was saying that safety is making sure that a machine does not hurt a human, and security is more about a human maybe doing something bad to a machine or to other humans, I guess, right?
Yeah, and exactly. And security is, in the context of software, really more meant what we classically know as cybersecurity. So this is the typical differentiation at the moment.
So what does Spleen Lab do then? Is Safe AI your central thing, or is it one of many things? What is your top approach?
So yeah, Safe AI is a very important thing where we are working on. In the context with AI, we all know that's a really unsolved topic, and there are many buzzwords out there like trustworthy AI, debugging AI, whatever. But this is a really important pillar because we develop software for autonomous machines like autonomous drones. For example, we work together with DroneUp, a big company in the US that do delivery, last mile delivery of packages for Walmart. We do precision landing, and their goal is to remove an operator in that automated process. So they need to fulfill specific requirements regarding safety when it automatically lands or automatically drops a package over some area. And here our product comes into the game. So we have a redundant approach to deploy robotics software, always with a part of AI. Sometimes it's 20% AI, sometimes it's 40% AI, but at the end it's a robotics application that fulfills a partially critical task and needs to fulfill some requirements regarding safety. So that's why I would say it's a very important pillar, what we have here, because our business at Spleenly could only scale if we solve it. Our approach is to do it iteratively. So we don't want to solve the full autonomy yet. So we say, okay, let's break it down in some partially automated tasks and take the big challenge iteratively. And this is our big vision. And we're working on more. We're working on full safe AI algorithms. We work on the full AI deployment, which needs to be safe. So there comes everything into the game. So the most important thing is we are working on embedded solution, but with a very, very strong focus on the current safety regulations.
Right. We'll get into a little bit more detail just in a moment. Maybe first tell us where, as in what markets are your customers? You just mentioned Walmart. You could almost say delivery, logistics, maybe also an industry, but not necessarily the majority. So where are your current solutions, your current customers?
Yeah, this is a very good question. So this also aligns with our vision. So we really deploy cross industries. So could be drones as work, vertical and industrial drones. It's also logistics, last mile logistics, but long-term logistics with trucking. We are also in the field of automated agriculture. We talk about automated tractors. Also, we are working in ADAS on the streets. So we see us here complementary, but there's also applications in the defense pillar. So this is our vision. So we can say that we are something like Mobileye in the drone industry. We want to become it off-road, and we are also complementary in the ADAS street domain. So these are our markets, and here we have everywhere very famous paying customers.
which maybe we come to in a moment. So let's get into maybe a little bit more detail of your offer, which I understand, or one of your offers is called Visionary Safe AI. What is it and how does it work?
Exactly. So the big challenge if it comes to autonomous robots is that every robot has a different design, every robot has a different sensor, and our approach is to keep it as generic as possible to support as many sensors that are possible. So we have solutions on industrial RGB cameras, but also on IR, radar, LiDAR. And then we, with the different solutions in the different verticals like agriculture, drones, ADAS, we can deliver to many, let's say, niche markets. And our offering is to deploy all this software stack to different chips. So there's NVIDIA, Qualcomm, TI. So there's a very heterogeneous target market of robotics, but we serve them all with our solutions. And when it comes to the offering, then we can tell, okay, we can provide you an RGB-based SLAM. We can provide you an RGB-based visual navigation or a LiDAR-based sensor fusion. And this is exactly the offering. We offer a spatial AI software stack for autonomy in visionary sensor fusion, visionary object detection, visionary free space, and visionary SLAM, which then ends in real functionalities. Let's imagine a drone does collision avoidance. A drone does GPS-denied operation. Parking car has the capability to predict free space on a very low-cost sensor like a low-cost camera. Or we do sensor fusion on L3 autonomous trucking. So this is our offering. And where we're really strong is that we are focused heavily on the embedded part. So we have a high-performance team, and that's why we can serve many different chips, like what I told before. And I guess this is a little bit the strong USP, that we are very fast in the integration part.
Okay, yeah, we come to that a bit later. Now, I understand that working with artificial intelligence, specifically neural networks, because of their statistical property, and I read about it again this morning, a huge discussion on LinkedIn, is your machine learning, is your large language model, whatever element of the AI world we choose, is it really statistical or is it maybe deterministic? I understand that because at least it typically has this statistical property, the neural network-based approach to safety has not yet been approved for safety requirements. How do you deal with that?
That's a very good question. That's exactly why we started Spleen Lab.
Okay.
To explain this a little more, you fully introduced it right. So classic algorithms that are in current automated, for example, driving systems, or for example, in approved other industrial robots, are highly deterministic. And the deterministic nature of their system design helps to approve towards we call safety integrity level. And this is also the pure idea behind functional safety, that you literally design a system that you can really say any possible situation that could happen, you can deterministically describe what you do, right?
Very quickly, deterministic, same set of inputs always gives the same output. Is that the right definition here?
Exactly. You can exactly describe what happens, right? And with a specific probability, but in which end, let's say, state you will land, and then something needs to be triggered, and a safety function needs to be triggered, for example. And this is the nature how the current regulations are designed, like what I told you before, right? The ISO 262, or industry, it's the IEC 61508. They really want some deterministic tree where all probability states are defined, and everything that could happen with the system will be described in the safety mitigation. And if it comes now to a neural network, you typically have so many parameters. So you all know these large language models, right? Even 70 billion parameters of a medium-sized large language model is almost impossible to tell in the terms of safety mitigation what could happen if you try out all permutations. So at the end, it's a statistical model. You're fully right. And then you need to design something that we call safety by design. You need to design watchdogs. What's typically done that you have a different hardware where a deterministic algorithm runs parallel to the AI, and that assesses the AI at the end of the day. So these are typical safety patterns, and only if it's really in the same area of their output, then the output is validated. And what we do is exactly similar. So we do safety by design, but we design software functions that assess the output of a neural network. And you may have seen this depth estimation post I have done also with the use of XLSTM. This is a good example to explain how we do it. So we include temporal consistency. So we designed, it's also patented, we designed some assessment function that deterministically describes the output of this depth map, which comes out of a neural network, the confidence. But this confidence comes not out of the neural network itself. It's a parallel path, and it's done with temporal consistency. So let me explain it a little more. So,
right. It sounds like you made a step going from probabilistic towards deterministic.
Yeah, it's kind of a mixed thing. Yeah. Because we take over the approach of self-supervised learning, where you have a loss function during training, which needs no human input. You transfer this idea to the runtime we call inference, and then you use this deterministic loss function as deterministic safety watchdog. And this works out quite well. We have shown it for depth estimation in free space, for example, for partially automated driving function. And we are very sure to achieve an SLB. We call it safety integrity level B. And this is quite a very important milestone.
Right, because was then, of course, going to be my question. So you're very close to receiving, and you are good hopes that you will get an approval. What is that from one of those specifications that you will get? What is basically a neural networks based system will get a safety approval.
Exactly, but really in a specific context, right?
I understand, but that context with your patented technology, you can use that technology in different other environments as well, I assume.
Exactly.
That's a big thing then, actually, because the way we started discussing this, and I think you're using the use case of autonomous in this case, but it sounds like you have kind of solved this, what I guess has been an issue, a problem for a long, long time, that, as you said, the regulations have always been written on the basis of 50 years of deterministic programming. And it sounds like you have found a solution towards getting approvals even on the basis of probabilistic neural networks.
Yeah, but I wouldn't call that so. It's not, from my point of view, it's not a rocket science.
Okay.
It's really understanding what we are doing there. I know it's a big thing, but this is maybe something you asked in the beginning. So where do we stand for? And I believe we're very strong in embedded engineering, very strong at the algorithm design, but we also have knowledge about the current safety regulations. And this triangle is very important if you design a system. And there's another important thing we faced, right? When it comes to AI on chip, you need to somehow execute the AI. And this execution of the AI, for example, could be an ONNX model or something. This execution, this software piece is also not certified yet. And this is also something we are working on, because if we solve the overall thing, then we also need to have a safe execution on the chip.
I will come back to this. I will come back to SLAM you mentioned. I will come back to XLSTM in 10, 15 minutes, if that's okay with you. Before that, I do want to look into 1-2 other use cases. Maybe you talked about, specifically autonomous here. I understand there is this in-flight use case you have as well. And maybe then let's move to SLAM, because SLAM is a technology or an approach that I know typically from robotics, but you've been using it, or one of your customers has been using it for in-flight use case. Can you talk about that a bit?
Exactly. So, when it comes to drones operations, automated mission, for example, also for delivery, but also in surveillance drones, right? We have a big customer, Quantum Systems, or it's a big partner. For the in-flight use case, so the SLAM solution is something we call visual odometry, or if you map everything, it's a SLAM. And at the moment, the system only relies on GNS signals and IMU, and this makes the system dependent on outer conditions, on an outer signal, or let's say on an active signal. And to do the operation more safe, and then we are back into the safety case, right? We need one more input, and that's where we come into the game. We provide a SLAM as a functionality that can provide a georeferenced position, and altogether makes the overall in-flight of an automated drone much more stable, much more precise in its mission planning, because it has a very, very stable geolocalization.
And SLAM is helping the vehicle, maybe the drone in this case, to know where it is, or to first map
exactly
an environment of what is around it and of where it itself is in it. Is that right?
This is an exact definition. So typically we differentiate between perceptions of what is around me and localization, where I am in the robotics field. And SLAM directly points to the second one. But as you told, fully correct. So you use signals, like a pure camera signal, and you try to create a 3D understanding of the surrounding due to video stream. So let's say temporal approach. And based on finding good features, you design a 3D map. This map could be sparse or could be very dense, so that different AI approaches out there. And based on this, you can estimate where you are, and then you have a kind of understanding in your map where you are. And if you match the measured map you get out of your SLAM algorithm with a global map, then you can get a position of your robot in global coordinates. So this is at the moment a very important approach, because it enhances safety and it also improves the accuracy.
One customer maybe you can share with us is, I understand, Deutsche Bahn, the German railway. What are they using this approach for?
At the moment, they are going into surveillance, right? They want to see something on their rails, right? To see if there could be a tree or something, and therefore they need an operation system that is kind of very precise in its fully automated perception approach. Therefore, they use for sure drones following the rails, and they need to be precise. And there are many, for example, how could we call it, signals that are toxic for a pure GNS approach, and this makes it more safe and more precise.
Okay, yeah, I live actually close to a railway track, and every day I do actually pass it a couple of times a day. And typically, I've always been on the outlook of one of the drones of Deutsche Bahn to see. So I'm looking forward to seeing them one of these days. You mentioned already XLSTM. So you had a first endeavor, I think your colleague, maybe yourself, XLM, and how to apply it in industrial setting. I was going to ask you also for the SLAM, because you have been using the word robot a couple of times, but maybe in combination. Let's first, why did you get into XLSTM, and what did you get out of your deep dive?
Yeah, I guess it's, again, a great question. So also, if we take into account what we discussed before, as I told you, it's all about temporal consistency, how we treat the safety, right? And we have seen transformers, and for us, especially vision transformers, outperform CNNs, and the results are really great in the recent years. But a little drawback is how the transformers are designed. So they split all the input into embeddings, and you either focus spatially on some image where you have some image patches you order and put into the transformer, or you have some temporal signal like a video stream. But here it's only a fixed focus, right? And it's very small. And the XLSTM has the capability to have a much wider look into the past, which makes it very, very, per design, very, very relevant for the approaches I told you before. So processing of video signals over time with the scope of functional safety. And this was our main idea to use it, because we think this temporal consistency approaches, they match very well with the nature of XLSTM. And that's why we moved into it. And we see lots of challenges are still out there. But what we found that, on our first glimpse, it's on par, or at least in the same range with vision transformers for our first trainings, for example, for the depth estimation. But we also want to check it out for free space and others. But then there is still work to do. But the main reason is really the temporal consistency, because, as I explained, this is the nature of our safety approach, and this matches very well with the design of XLSTM.
Okay, sounds good. And in addition, I understand XLSTM may be more suited for your embedded deployment as well, and faster actually in a time of inference or also training time.
Yeah, it's more suited. It's more suited. There's a very, very strong advantage. So it's the kind of processing dynamic size of input parameters. So if we come back to the SLAM, for example, if you imagine you're in an environment, less number of features, right? 4 features you can match with the next frame, or you're in an environment with many, many numbers of features. You have some different size of input into a specific neural network based on some backbone. And here it could suit very well, because it's per design capable of processing dynamic input sizes. Again, when it comes to different resolutions or all these things. So there it really makes sense, because on a transformer you only have a fixed size of inputs, you go workarounds, and it works quite well. But here for it's very, very well suited. And on top, is that's what the paper propose, it could be more efficient on the onboard execution, and because transformers are expensive in the sense of costs we need to execute. And this is at the moment shown in the papers. At the moment, it's not true on the device, because there still needs works to do that make the XLSTM more efficient on execution. I mean, the implementation, right? Because there's lots of work done on transformer side, but per nature, it's more efficient. And then it could run faster. Then we have more safety. That makes it very well suited.
Okay, one final question towards us being the Industrial AI podcast. As we talked about SLAM, as you've been using it, and you've been using the term robotics a couple of times, maybe in a different sense, but sure. I mean, talking about robotics in an industrial environment, could your approach be used in such industrial robotics environment as well?
Yeah, could be fully used. At the moment, we don't have so many customers in that field, but it's for sure an idea we want to go. Also in warehouses, we already had projects also together with drones, to be honest, but really on fixed robots, it could be also used. So our approach is agnostic. So we are agnostic towards the sensor. We are agnostic towards the deployment on the chip. So yes, it could be used. And the good thing, the safety is also towards industrial safety standards, which I told before is very similar to automotive safety or medical safety or even aerospace safety. And that's a fun fact. These mitigation strategies are very similar.
Yeah, you explained this, that your patented approach allows for moving from a probabilistic to a deterministic approach. Now, as you mentioned, I think I've seen maybe some videos somewhere of drones in warehouses. What would be, if at all, you say you're agnostic, so which means in the end you don't really care is a big word, but assume you're open for customers, also for listeners, customers in a typical environment, industrial setting. But what would you say, because we have heard lately so many times about the humanoids and even humanoids in an industrial environment, and we've had this discussion a couple of times. So I have a fixed robot, or I have a robot which is like a human, or I have a robot which maybe I put on wheels. Doesn't look really human anymore. But then there is the option of a drone, as you say. You have any view on where you see the market moving, kind of thing? Is drones going to be the thing? And because we have drones, we don't need kind of humanoid or fixed robots?
That's a really tough question. So what I have seen is that drones are always underestimated, and simply by the reason they could fall down. And please trust me, this is really the thing. Everyone thinks a drone is very easy, but it is not, to be honest. And in the industrial setting, you rely purely on SLAM, right? SLAM in the sense of localization, because there is no georeferenced GNS signal. So yeah, I believe there's still some work to do with drones in the industrial environment. Some drones are wired drones, and they are combined with a ground robot. And this was also something we did in the past, and that I believe some teaming in this sense makes sense. But you also told, the human need approach is a thing, and I don't have a clue, but I feel it turns to the human needs, because nothing else needs to be changed. I have no clue how expensive they will be, but this is my opinion on that.
Yeah, I've heard that reasoning for why, but it's a different discussion. I'm not sure I can understand it in a transformation approach, for whatever the next couple of years until, so we can use existing factories. But I'm a stronger believer in, if we have a structural new way of doing things, we can make new, factories. And if in the new factories we're going to have, it doesn't matter what we're going to have. Maybe we're going to have drones, could be. And we're going to design that factory with drones. So then, yes, in the meantime, we can have humanoids, because, factories have still been built for machines plus humans. Different discussion. Tell us about your team, where you base. Maybe you're looking for new colleagues. If so, what should they bring?
Yeah. Oh, this is something I need to emphasize, right? The team is the greatest part of Spleen Lab. And we're really talking about our software engineers. We are currently about 45 people at Spleen Lab, located in Jena. Jena is a tech city in central Germany. You can with a very, very traditional university and a very strong, let's say, university landscape around. And this is where we founded Spleen Lab, because the core team settled down there, and then it was obvious to start there. But it was the right decision, because there's a good location, there's a strong universities at other big companies like Zeiss, Jenoptik, but also NVIDIA certified camera producers like Light Vision. So there's also a good ecosystem. And the most important thing is that we have a loyal, strong team. And it's an international team, but mixed of robotics engineers, AI engineers, and pure software engineers. But this is mainly the feedback. And we are always looking for new people. We have no specific roles open, because we believe in a way to insert people that they can really put their most important strength into the company, that it's most worth for us and adds the most value. So it's most efficient. And this worked out most of the time very well. And if someone is really interested, then he can always apply. We have some open roles, but the main meaning is to attract it to people that may feel that they are good in that space.
I understand. Thank you very much for that. So if one of you, dear listeners, feel maybe you would like to work together with Stefan and his team in this great safe AI environment, you can best contact him on LinkedIn, Stefan Milz, MILZ, and that's the German word for what did we say, spleen, right?
Exactly.
Yeah, it's one of your ways that people, I think you're right. It's one of the ways that people that are going to know exactly who you are. So otherwise, if you, dear listeners, if you have any other question, comment, as always, please send a short email to peter@aipod.de. I'm very happy that you stayed with us so far. Looking forward to have you with us again. And Stefan, thank you very much for your time. And
one side note, maybe.
Please.
We are really looking for some salespeople. This is where we are.
Oh, wow. Okay.
Not too strong. So if someone is in the sales field, either others or agriculture or whatever field, or has really the ambition to work with us. So this is something where we are not well occupied, and I think it's a great opportunity.
Thank you, Stefan. Noted. Take care and bye-bye.
Thanks a lot for having me. It was great discussion, really good questions. Thanks a lot.
Really good answers from your side.
Okay, thanks.
Thank you, Stefan.
Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber.